Welcome back from break, everyone. Our next talk is a remote talk where we will learn why managing vendor access in AWS is nearly impossible. Before we get started, I'd like to thank our sponsors, especially Netflix. Netflix is the world's leading streaming entertainment service available in over 190 countries. We push unprecedented cloud technological boundaries to efficiently deliver streaming services at massive scale over the internet. Come help us secure this massive footprint in the public cloud with a combination of innovative and unique cultural challenges. Our current job openings are at jobs.netflix.com/teams/security. We will take questions after the talk, both in person and via Slack. Now, please welcome Yoav.
Thank you very much. And again, thank you for the organizers and sponsors of this conference, one of my favorite conferences year-round. Yeah, today I will be presenting about managing vendor access in AWS and the difficulties that comes with it. Just a little bit background about myself. My name is Yoav Nathaniel, and I'm a cloud security architect at Goldman Sachs. I'm responsible for kind of the firm-wide cloud, so not any specific business line or application, but rather everything that the firm does in cloud. We'll dive a little deeper into kind of some of the challenges that we're seeing when working with the public cloud infrastructure. So a few things to know about vendor management. More than half of organizations were breached through their vendors. And even more than that, where are organizations that don't even have an inventory of how we're vendoring accessing their infrastructure, who is accessing, how are they accessing, and so forth. And primarily, this is because of the lack of the centralized controls, the complexities of their environments, and the frequent vendor turnovers. People are changing vendors. There's also the concept of tribal knowledge. So only specific teams know about a given vendor agreement, while others really have no clue about it. And so from a centralized cloud governance perspective, how do you always stay in touch and are aware of whatever everyone is doing in their environments? One thing to note, just about the scale of kind of the problems that we deal with, we have thousands of AWS accounts, and we have about 10,000 or 11,000 engineers in the firm. And so it's impossible to actively communicate with all of them and know about everything that's happening before they do it in advance. And so this allows us to essentially stay in the loop with them, to actually make sure that we don't encounter the same issues that we're seeing in the industry. And so the approach that we're going to be using to solve this challenge of who's accessing our cloud is we're going to essentially discover it, and we're going to discover it within our cloud infrastructure. Let's dive in a little deeper as to what that actually means and understand why it's a challenge to actually discover things. And so first and foremost, we have to understand what it is that we're trying to achieve, what are the challenges that we're seeing in the cloud, and so what does that mean in terms of a workflow perspective, especially in the enterprise context. So we want to understand what is considered internal versus considered external. Internal can also mean a few things. So internal to a specific department or internal to the firm. And so there's a lot of different levels of granularity. For all intents and purposes, I'm going to keep internal as internal to the firm, while external means external to the firm. And so these are extremely external vendors that we now have to worry about because they're outside of our domain and our ability to kind of manage. And so we want to set up a perimeter around our AWS organization. In some cases, you might have more than one AWS organization, which makes it even more challenging. Then we want to understand what protocols and schemas we're going to be working with. It's nice and easy to say that we're going to be working with AWS API, but it's not sufficient. There's a lot of ways to actually interact with AWS components. So, for example, SNS can interact with other resources using AWS proprietary mechanisms, as opposed to an EC2 instance just making a network request, which is just, let's say, HTTPS. And so you have to understand all of the different protocols, schemas, and ways that things can interconnect in order to approach this. And last but not least, we want to kind of have a managed process to keep track of what's approved, who's using what, and so forth. That's always staying up to date. And so we talked about an inventory. And so there's two types of inventories out there. There's a managed inventory and a discovered inventory. A managed inventory is what's commonly used in on-premise systems. And it's not really a good use case for the cloud because essentially when the user wants to perform something, the user usually has to enter some type of a workflow to make a request. That request is registered in the inventory, and then IT fulfills it. It could be that it's registered or updated again after the fulfillment. But that essentially allows IT to keep track of what are users doing and fulfilling and knowing what's out there. And so it only knows what has been created through the workflows that have been given to the users. If something is created outside of the workflows and it's not recorded at the time that it's being fulfilled, then it might not end up in the inventory. And so we want to avoid it when we're using public cloud systems, especially when you're using a lot of different accounts and everything is asynchronous. And so a discovered inventory, which we think is more suitable for cloud environments, is one where a user or IT can request something, fulfill something, and they essentially create resources and configurations. And they don't really need to report it to anybody. The inventory, the discovered inventory, will make sure to keep synchronized. It will automatically update and discover the resources and any changes that happen to them asynchronously behind the scenes. So users really don't have to worry about it. If they're using an approved workflow or they're using an unapproved workflow, it's still going to capture it. And so you can think of it, the biggest difference is that the discovered inventory has a catch-all mechanism. In case the user does something in a workflow that's not really approved, we will still capture it no matter what. And so how do we go about managing AWS or managing vendors in AWS organizations? And so from a process perspective, it's pretty straightforward. One, you create a discovered inventory. We're not going to go into the nitty-gritty details of that, but you can use either open source tools. You can just query the AWS API. You can also use AWS config. There's a variety of ways out there, and there's actually a variety of tools out there that create an inventory for you. One of the biggest challenges with creating a discovered inventory is understanding all the different schemas that come up with all of the different AWS services, and actually integrating with all of the services, because there's just so many types of resources out there. The second thing is you want to be able to discover or check for any resources that might have external dependencies. And that can mean inbound access or outbound access for the most part. And so you want to be able to detect that, to have some detection mechanism. The third thing you want to do after you now understand how are you being exposed externally, you now want to be able to classify external dependencies with a list of known vendors. Now, when you start off on this process, you're going to start off with 0 known vendors. If you're a little bit more sophisticated about it, you might be able to automatically detect the publicly known vendors because they keep a list of things that are public. Oops, my bad. And then you want to take anything that's unknown to you from the external dependencies. You want to review it with the engineers and add it to the list of things that are now known. And whatever external dependencies that are suddenly known, wherever they appear in the system, so let's say an IP address was unknown to you and suddenly it's known, if you saw it in 400 different locations, you can now remove all of those external dependencies because they're the same one. They're going to the same exact vendor. And so if you for step 4, if you can't trace it back to any external dependencies, no one can claim what vendor it is or can put a label on it, and it's not approved, then you need to remove the external dependency and essentially remediate it. Finally, for step 5, in some enterprise use cases, you might want to repeat steps 3 and 4 for internal dependencies. As I mentioned, sometimes you want to know what's internal versus external to a specific department. So it's within the organization itself. It's not just inside or outside the organization, but there's additional complexities within the organizations, especially around regulations, red tape, and so forth. And so now we're going to look at some common examples of things that we're seeing that are supposedly unmanaged in AWS, and we need to kind of make sure that we manage internally. So first thing is the external resource policies. In AWS, you have a concept of a resource, and the resource can have a policy attached to it. So effectively, that resource can be external, can be accessed from an external account. And that means that the resource effectively has a perimeter around it that's independent of the perimeter of the account, of your own account. And so you need to make sure that your resources are not being accessed from external accounts by looking at the resource policies. One of the things that we've been using is Access Analyzer, which is an AWS service that helps detect external access to your resource policies. It detects 6 types of resource policies, and hopefully in the future more. So just make sure to pay attention to them to understand which accounts are actually able to access let's say your IAM role. And so in AWS, if you see an AWS account ID, it's just a few numbers, it's gibberish. But you actually need to put a label to that to say, you know what, this account ID actually belongs to this person. And you need to do it across the board for all of your different accounts. And then a different type of access is external AMIs. So if you're using EC2 instances, the AMIs are essentially the images that your EC2 instances are going to be running on. And every AMI has a concept of an owner. It's an attribute that you can see next to the AMI, which essentially indicates which AWS account owns and manages this image. And so it's effectively the one that published and distributed to your account. Now, there's 2 different mechanisms to actually distribute an image. 1, you can copy it to another account, or 2, you can share it. We highly recommend sharing the image in order to maintain the owner attribute. That allows you to trace it back to the original owner, as opposed to when you copy, it actually overwrites the owner attribute, because whoever you copied it to is now the new owner of that AMI. And so suddenly you don't have a good way to trace it back to the original owner. And so both AWS and vendors within the AWS marketplace even will share AMIs with their customers. And so when you look at your EC2 instances, you want to see which ones are using AMIs that are managed by your organization, if you have a mechanism to manage them, or which AMIs are managed by external vendors, and if so, which vendors. Again, you're going to be looking at AWS account IDs that are just a bunch of gibberish, and now you need to understand which organization is actually behind that AWS account ID. And so sometimes you might be able to have like an internal image factory that actually allows you to create your own AMIs. If you want to track that as well, you can just, for all intents and purposes, keep it as another vendor in your list. Then now we're looking at external VPC endpoint services. So this is talking about outbound access. If you guys are not familiar with VPC endpoints, it's actually a service that's using another service in AWS called Private Link. which allows you to communicate with services on AWS over private IP. So you never have to use a public IP to actually communicate with other services. And so a VPC endpoint allows you to get outbound access to connect into a VPC endpoint service, which exposes inbound access. And so as you can see on the diagram on the right, your VPC endpoint is able to connect to an external service using the VPC endpoint service DNS, which is globally routable from any AWS account to any AWS account. As long as you're in the AWS ecosystem, you can essentially access other organizations over private link. And there are no good controls around it. It's even more challenging because if you look at the example DNS, and I'll highlight it with my cursor, you can see that this is effectively meaningless. There's no label on the VPC endpoint service DNS. It doesn't really indicate anything besides what region it's in. And so there's no way for me to understand if it's mine or if it's a vendor's and which vendors. And what you sometimes notice is, for example, if you're connecting to a third-party vendor, like a Datadog or a Snowflake, then sometimes a lot of different accounts will connect to the same VPC endpoint service, because sometimes you'll have shared tenancy. But sometimes they'll connect to unique VPC endpoint services because you might have dedicated tenancy for some applications. And so these are randomly generated, and it makes it much more difficult to identify it just without talking to the engineers. Oftentimes you need to speak to the engineer or get some type of line of communication in order to identify what actually stands behind this. And so one thing that you can do, it's not very convenient to actually configure, but I highly recommend, is to configure the private DNS names. And so if you're creating your own VPC endpoint services, you can set up custom DNS for them to identify them. So at least your internal ones you can identify. Okay. Another example is external SNS subscribers for outbound access. SNS can send notifications to a variety of different services using a variety of different protocols. And so it can do it over email, over API, SMS, or even directly to AWS resources. And so tracking if an SMS number is, or phone number is within your organization or not, if an email is within your organization or not, or an AWS resource is within your organization, becomes very, very challenging. And it becomes even more challenging when SNS actually does it over the public internet. It cannot be placed within a VPC or locked down and so forth. One popular example of people using SNS is for PagerDuty. If you want to trigger an alarm to trigger a PagerDuty incident, you can use SNS for that to actually make the notification go to PagerDuty. The tricky part about this is that, as you can see, the events.pagerduty.com DNS is multi-tenant, and so it's hard for you to understand if it's going to an external PagerDuty or not. If you're just looking for the vendors, events.pagerduty.com might do the job. But if you're looking to verify that it's actually going to your endpoints, you might need to be more granular than that. And so what we recommend is actually limiting the number of protocols to like 1, 2, or maybe even 3 protocols whenever you use SNS to make it actually feasible to kind of keep track of this. Now, one last item, we'll touch upon it very briefly because we need to move on to Q&A. Just internet CIDR blocks in security groups in AWS, which are used to control traffic to AWS network interfaces. You can have it for inbound rules or outbound rules, and you can configure public CIDR blocks. And so if you're configuring public CIDR blocks, you want to make sure that you identify exactly all of the CIDR blocks that exist out there in your systems and tie them back to the specific vendors. And if a vendor does not have a static list of CIDR blocks and you have to use 000, you should probably avoid that vendor, but if possible. I'll give it back to Chris and team to start off the Q&A session. Thank you, guys.
Thanks, Yoav. So a couple questions. So you've identified a number of ways to identify vendors. A question I have is, how do you correlate those back to other vendors? Like, is there a master list somewhere of account IDs, DNS names that you share or you'd recommend we use or collaborate on to identify these?
So I don't believe that that list exists as a public resource today. We maintain a list like that internally. I think it's something that probably AWS should take the forefront of and take lead on. Otherwise, it would be useful if there would be like a public registry of AWS account IDs, where you can essentially tie back an AWS account ID to the owner. I don't believe that exists though on a public level.
When you discover these use cases of both inbound and outside inbound and outbound access, like how do you track them back to who is responsible for that within your organization? So these will tell you that it's happening, but how do you find sort of the source and justification for these things?
Yeah, so for that you need to maintain kind of a database of owners of every AWS environment. And reach out to the specific owner and make sure to identify what it is. Now, sometimes you have 5 different owners for the same, let's say, CIDR block. And so you don't actually need to speak to all 5 of them. You just need to speak to one of them, and you can identify what that CIDR block actually means.
Any other questions in the room? All right. Well, thank you very much, Yoav. Next up, we have audit metrics as drivers for zero trust and cloud automation, and we'll be back in this room in about 6 minutes. Thanks, everyone.
Thank you very much.
Thank you, Yoav.